All right, I am going to show you how to do 4.2 and show you some of the notes in case the distributive property doesn't really make sense to you. So the first thing that we need to do is do vocab. So expanded form is an expression written as a sum of terms. That's the definition. So let me see if I can give you an example. I think I'll go back and do that in a minute because I want to cover the other one first, I think. And then the next one is factored form. Which would be an expression written as a product of the common factor and the sum of the other two factors. So then they show you a picture and they show you 20 plus 35 equals 55. So these are all integers, right? These are all three of these are positive numbers. So you could write that as 5 times 4 plus 5 times 7, which would be 55, but they're going to write 5 times 4 plus 7. And they show it to you in the picture next to it, but I'm just going to do like a simplified version. So we know that this side is 5 and this side is 4 and 7. So then this would be 5 times 4, which is 20. And then this would be 5 times 7, which would be 35. And then altogether it would be 55 if you added these two things. But factored form would be writing it as the steps. So 5 times 4, 5 times 7, and then this would be the factored form. So the number that they have in common is 5, and then the sum of the other two factors would be the 4 plus 7. So this is factored form, this is expanded form. And then they give you another example with variables, which I know scare you guys to death, but it's okay. So that one is 40. You can't see that. 40. I'm doing this right out of the book, by the way, on page 81. 40 plus 8x, you can write that as 8 times 5. And 8 times x. 8 is the number that they have in common. When you look at that, you could be like, well, there are different ways to make 40, but there's only one way to make 40 that involves an 8. So you could write it again as 8 times 5 plus 8 times x, which would be number in common times other two factors added together. And then my beautiful rectangle divided up, number in common, and then side lengths. So 8 times 5 is 40. 8 times x is 8x. 8 times 5 plus x. So that's basically like the whole point of distributive property. But you can also do all of that with negative numbers as well. Even though we kind of talked about with a square, there's no such thing as like a negative amount of space, at least at this level of time. So this time I'm going to do with integers, so positive and negative numbers. And they give you two examples, one with a variable and one without. So the first one is negative 3 times 4 plus 8 would give you negative 3 times 4. So we do it one step at a time, plus negative 3 times 8. So you would take this number and multiply it by everything on the inside. And then their other example is negative 2 times x plus 6. You don't have to put that dot there. That's kind of redundant, but I think they're trying to help you like condition yourself into using the parentheses. So they kind of do it step by step. So if I were you, I would pause and see if you can figure out what the expanded or the factored version of this would be, like even more. And then like come back and see if you were right. So again, you would do this negative 2 times x, that's the first one, and then negative 2 times the positive 6. And then it says when you apply the distributive property to rewrite 5 times x plus 5 times negative 2.5 as 5 times x plus negative 2.5. Remember the brackets are, if you already are using parentheses, then you'd use brackets next. You are factoring out the common factor 5 from the two parts of the sum over here. When you write the equivalent expression here, you can say you have factored the expression into the product of two terms, 5 and this. And then they ask you if negative 2 times negative 3 minus 7 and 2 times 3 plus 7, if those are going to be different answers. And with your knowledge of negative numbers and subtracting, going backwards on the number line and things like that, you should have an idea just by looking at this if the answers are going to be the same or different. So as we learned, you would do what's in the parentheses first. So negative 3 minus 7, you're already in negative land and you're going further into negative land. So that's going to put you at negative 10. This is you're just in positives here. So this is going to be positive 10. And then you have negative 2 times negative 10. We know two negatives make a positive. So this is going to turn into positive 20. And then because these are both positive, it's going to be positive 20. I think it's important here to recognize that there's a negative here and negative, that like this is going to be negative. Anyways, moving on to the actual problem. Oh, aggressive. Whoopsie. That's an A. Okay. The checkbook shows Juan's bank account balance at the beginning of the week. During the week, he withdraws. So balance means how much you have right now. During the week, he withdraws. So he has some amount. Okay. And he withdraws, which means takes out $19 and another $30. How much money does he have left at the end of the week? So number 1 says, show 2 different ways to solve this problem. So again, it doesn't tell us how much money he has like in his bank account right now. Oh yes, it does. Oh, it's in the picture. Oh, you guys, they hid it. It's in the picture. If you look at the little picture of his checkbook, it says his balance is $100. Oh, they almost snuck one past me there because I didn't look at the picture. So he has $100, which unfortunately for him is not a whole lot. And then he's going to take out the $19 and take out another $30. And that's going to leave him with $51. But they want to know a different way that we could do this. So you could say that he has $100 and he is getting rid, or he has taken out a total of 19 and 30 together, which if you were to put that, like if you were to do order of operations, you would end up with 100 minus 19 plus 30 is 49, which would give you 51, an answer of 51. So he spent almost half of his money in one day, which is definitely how it goes when you are a poor college student. I'm assuming he's in college. I don't know that for sure. Number 2 says, describe how the 2 ways are different. So basically you would say for the first one, for way number 1, I guess I should label those number 1 and 2. So way number 1 is just shows it's like a number sentence that shows total minus the withdrawals. How do you spell that? Withdrawals. I'm guessing withdrawals. I think it's like that. And then the second one, number 2, is total minus total withdrawals. So they're just not together in this one. You're not taking them and putting them together. Part B, it says use the distributive property to write each expression in expanded form. So this is the practicing part that I really wanted to get to so that you guys can see how to do this. So it is 5 times 3 plus 2. So as I move through these, I want you to pause and try it on your own and then see how you do. But you have to pay attention to what the direction says. So you're going to write each of these in expanded form. So you're going to break them apart like it did up here. Okay, so that's what we're doing right now. So we're taking that and we're going to break it into, okay, so it's 5 times 3 and 5 times 2. That's all you have to do. You don't have to find the answer yet. Number 2 says 5 times 3 plus negative 2, which would be 5 times 3 and 5 times negative 2. Number 3, 5 times, oopsie, it doesn't have a bracket on that one. 3 minus 2, so 5 times 3 and 5 times negative 2. And number 4, 5 times bracket 3 minus negative 2. So this would be 5 times 3 minus 5 times negative 2. Yeah. Oh, and then number 5 says find the value for each one. So now we're going to go back through. These equal, so this is number 5 up here. I'm just going to put it up here. Can you see that? Nope. Yikes. There we go. Sorry. 25, 15 plus 10, and then 15 plus negative 10, which would be positive 5. Another 15 plus negative 10. Wait, did I do that right? Oh, I guess maybe I should have that on there. I think I technically wrote this one wrong because that's a minus, so that should be a minus right there. Yeah. I'm going to change that to that. So 15 minus 10 would be 5. And then this would be wrap that in brackets. This is in brackets. I think that's what I forgot was the brackets, because that's important. Because this is now going to make this answer positive 10, which is going to make this 25. See, these things, they matter. Okay, and then moving on to part C. Use the distributive property to write each expression in factored form. So now we're working backwards of what we just did. So they're giving us this, and we're going to write it in factored form. So looking at this, the number that they both have in common is 6. So I'm going to write 6, and then the 2 are going to be, the 2 other numbers are going to be added together there. And then number 2 is, this is 4.2 continued. 6 times 2, subtract 6 times 3. So the number they have in common is 6. And then in here is going to be 2 minus 3. Number 3, negative 6 times 2 plus negative 6 times 3. So they have negative 6 in common this time, and then 2 plus 3. Number 4 is negative 6 times 2 minus negative 6 times 3. So they both have a negative 6 in common here, but it's going to be 2 minus 3. Number 5, 5x minus 8x. Now, I expect if you're going to get stuck somewhere and get confused, this would be it. So looking here, clearly the 5 and the 8, that is not in common, but what they do have in common is the x. So this time you're going to pull out the x, and then inside is going to be everything that is left, which would be 5 minus 8. And then number 6, with that new knowledge, hopefully you can do this one. So again, negative 3 and negative 4, they don't have that in common, but they do have the x in common. So that's going to leave you with a negative 3 minus 4. It's not minus negative 4, okay? Number 7, explain how to factor an expression with subtraction. So you are going to Identify the factor they have in common. And then you put that on the outside of the parentheses or brackets. Remember, these are brackets. And then the sum or difference of the terms goes inside the parentheses or the brackets. All right. There's like more practice that you could do if you need to in the homework section. On pages, let me see here. 87, 13 through 18. There's some practice for you there. They really don't give you a ton of practice on this because you're going to do this more next year too. But hopefully this was helpful for you and to learn like why, what the distributive property is for. Like this is basically it. As long as you can go back and forth on this, like that's it. Then you're good to go. Okay.